Hi everyone, it's Paddy here from arithmetichub.com, thanking you for choosing this video, but reminding you that whilst this is one method to solve questions like this, it's not the only method. With that being said, let's explore this concept a little bit further.
Hi everyone, so today we're going to have a look at equivalent fractions. So let's start off by talking about what equivalent fractions actually mean. Well, equivalent fractions, it says in our method, means different fractions that are worth the same amount. Notice how equivalent looks and sounds a little bit like equal. It's quite handy to remember and to help us remember that, okay? So, equivalent fractions, they're fractions that are equal. So they're two different fractions that are equal. So you might see, for example, you might have a half, and a half might look like something along the lines of this. But you might also have something that looks like this, 2 quarters. And if it's split into quarters, you've got exactly the same amount. 1/2 is this, 2 quarters would be that. They're both worth exactly the same amount. So they're equivalent fractions, they're equal, they're worth the same, just this one is at 1/2 and this one is 2 quarters. So you've got 2 parts when it's split into more parts, and here you've got 1 part of where it's split into less parts, okay? Split into 2 parts, you've got 1 of them, split into 4 parts and you've got 2 of them. Either way, you've got the same amount. So, equivalent fractions, different fractions that are worth the same, they are equal. And what's important to remember for this method is the idea of whatever you do to the numerator, you also do to the denominator, or whatever you do to the denominator, you also do to the numerator. Remember, numerator is the top half of your fraction, but denominator is the bottom part of your fraction. And then the third part says annotate on your arrows. Now I think that's really important when we're doing this. I think it just makes it really easy, really helpful when we're answering these types of questions. So, speaking of which, let's have a look at this one. Find 3 equivalent fractions for 2/3. Now, this kind of question is interesting in calculations because this is one of those questions where it gives you free rein to write whatever you want. You could do 28 times both of them. You could do 2 times 28 for your numerator, 3 times 28 for your denominator, and find the equivalent fraction like that. What I would say is, why? Why would you do that? You don't need to make it difficult for yourself. When we're working in maths, we want to make things as easy for ourselves as possible, and we want to be as efficient as possible and give ourselves as few opportunities to make mistakes as we possibly can. So why not just go for some really easy equivalent fractions? Whenever I see a question like this, whenever I've worked with any of the classes I've taught, what I've taught them to do is do the same every time. I've said, right, pick 3 that are really simple, really straightforward, and do the same every time. So, here's one example for my equivalent fractions for 2/3, okay? So I might say, if I've got 2/3, I'm going to start off and I'm just going to say, I'm going to multiply by 2. And I'm going to multiply my numerator and my denominator by 2 to find an equivalent fraction. 2 times 2 is going to give me 4, 3 times 2 is going to give me 6. That's one way that I can do it. Nice and easy, nice and straightforward. Let's have a look at another example, okay? So I might say if I'm doing 2/3, I might say this time I'm going to multiply it by 10. So I'm going to say times 10 is an easy one to do, so I'm going to multiply it by 10. Now when I'm doing my arrows and I'm annotating on my arrows, notice it doesn't really matter which way around I'm doing my arrows. I can do them whichever way around I want. All I need to know is that I've got my numerator and my denominator here. So, and I'm doing exactly the same to both sides, multiplying both of them by 10. Multiply my numerator by 10, multiply my denominator by 10. 2 times 10 is going to give me 20, 3 times 10 is going to give me 30. It's an equivalent fraction, it's still 2/3, but 20 over 30. Actually, when I do these types of questions, the ones I really like and the ones that I think are the simplest, most straightforward way to get these correct every time is if I've done times 10, what I might do is I go, okay, I've already done times 10. Now rather than doing, for example, 2/3 and then multiply it by 3 or 4 or whatever, what I might do is I'd do 2/3 times 10. So I'd do 2 times 10 is 20, 3 times 10 is 30, and so my equivalent fraction I've multiplied both by 10. Then I might do 2/3, and this time I'm going to multiply by 100. 2 times 100 is going to give me 200. Just make that a little bit neater. 3 times 100 is going to give me 300. And then what I might say is, okay, I have to find 3 equivalent fractions. I've already found my 3 here. But actually, whilst I'm going with this, maybe I don't want to times by 2 on both sides. Maybe I want to multiply my numerator and denominator by 10. Then I want to multiply my numerator and denominator by 100. And then I'm going to multiply my numerator and denominator by 1,000. So we've got 2/3 here. I'm going to do multiply by 1,000, multiply by 1,000. 2 times 1,000 is going to give me 2,000. 3 times 1,000 is going to give me 3,000. They're still equivalent fractions. 2/3 is the same as 2,000 over 3,000 in the same way that 2/3 is the same as 200 over 300, or 2/3 is the same as 20 over 30, or 2/3 is the same as 4 over 6. But what I've done is I've just kept it really easy because I've said, well, I can do times 10, 100 and 1,000. I know how to do those really well. And it keeps it looking really uniform so I can see, right, okay, does this make sense? Well, I've moved this one place value place, and I've moved this one place value place. I've moved this 2 places, I've moved this 2 places, I've moved this 3 places, I've moved this 3 places. Nice and easy, really great habit to get into. And once you're used to doing that for these types of questions, you'll be able to fly through them as soon as you see it. It's just like, okay, I'm going to multiply both by 10, multiply both by 100, multiply both by 1,000, okay? So, let's rule off from that one, and let's have a little look at the next bit that we've got here. Right, so let's have a look at this question here where we've got 3/3 is the same as something over 21. Now, you might have seen it looking like this when you do your set of calculations. That's fine, that's the way it's set out in calculations because it's just so much easier to make the computer set it out like that than it is to make it set it out like that. So, when we're looking for these types of equivalent fraction questions, what we've got is 3/7 is the same as something over 21. So we're still looking for our equivalent fractions, and we know the method for that. We've done it up here. So we know what we do to the denominator, we need to do to the numerator, or what we do to the numerator, we need to do to the denominator. So what we need to do here is check, right, what information do I actually have for this? Well, I know I've got 3/7 is the same as something over 21. Now I can't see what I've multiplied 3 by to get to this box, because I don't have all the information that I need. But what I can do is say, right, well, actually I know what I've multiplied 7 by to get to 21. I know that 7 times 3 is going to give me 21. I can check it if I need to. 7, 14, 21, yeah. 7 times 3 is going to get me 21. So, if I've multiplied the denominator by 3, because I know my method here, part 2 of the method, whatever you do to the numerator, you also do to the denominator, or the other way round, whatever I've done to my denominator, I'm going to do to my numerator. So, I multiplied the denominator by 3, so now I'm going to multiply the numerator by 3. 3 times 3 is going to give me 9. So 3/7 is the same as 9 over 21. 3/7 is the same as 9 over 21. On this one, it's the same, but this time we have both of the numerators and we don't have the denominator. So again, I'm going to use exactly the same method for this. I'm going to see what information I have. What is the information that I know? Well, I don't know what I've multiplied 12 by to get to the missing number, but I know what I've multiplied 11 by to get to 99. I know 11 times 9 is going to give me 99. I also know whatever I do to the numerator, I do to the denominator, or the other way around. So all I would do is say, right, I've multiplied the numerator by 9, so I'm going to have to multiply the denominator by 9 as well, aren't I? And then I would do 12 times 9, and 12 times 9 is going to give me 108. Okay? 11 over 12 is the same as 99 over 108.
If you found this video useful, then I would massively appreciate you liking the video and subscribing to the channel. If you want to explore more methods or practice using the method we've looked at here, why not check out the teacher videos at arithmetichub.com. Arithmetic Hub has videos just like this on different methods, specifically targeting areas needed in Key Stage 2. There you can practice one particular skill, or generate your own sets of calculations designed to challenge your understanding of all the topics covered in Years 3 to 6.